So today, instead, our learning goal is going to be, I can use the properties of exponents to simplify. So we're going to just do some exploring here. We're not going to take any shortcuts in this first one right here. This is, I want you to put a box around this. Product of powers. This is the part that gets tricky. Understanding what's really happening within a problem and which property you should apply. So this one we're going to explore is the product of powers. What does product mean?
The random result.
The result you get when you do what? Multiply. Yeah, the result you get after multiplying. And powers is when we have something being raised to an exponent, correct? So product of powers means you're taking a power times another power and maybe even times another power, but there's multiplication of powers going on is what's happening. So let's explore, what does 5 to the third power really mean? I don't want to know what it's equal to, I want to know what it really means, okay? Aurora?
5 times 5 times 5.
Yeah, so that means 5 times 5 times 5. So this one right here is really this. Let's put it that way, okay? And then times, and 5 squared means what class? 5 times 5. So 5 times 5 is the 5 squared. So what we really end up with is how many factors of 5?
5.
5 of them. These are all factors. 5 is a factor, times 5 is another 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 factor. We have 5 factors of 5. So we could say this is really 5 to the 5th power, isn't it? It's a shortcut way of writing 5 factors of 5. 5 to the 5th power. Okay? So go ahead. Why don't you do B, showing what does it really mean? And I don't want to know what, I don't want a value. I want a power for your answer. I want a simplified power answer from you. So what is the simplified answer is written as a power for this one? 3 to the 5th power. What power is this
1.
1? When you don't see a power written, it's always to the 1st power. Not the 0 power, but to the 1st power. Okay? So a to the 5th times a squared. Let's do that one. This is how many factors of a? 5 of them. So this is what we were practicing in our homework for today, getting us ready for this. This really means 5 factors of a, and this one means 2 factors of a. And altogether, how many factors of a do we have? 7 of them. Now, try to take a to the 7th power on your calculator so you get an answer. So your work? Only if what?
If that's the number digit before it.
Only if you know what a is going to be equal to, right? Yeah, only if you know what a is going to be equal to. Okay, and then how about D? 4 squared times 3 to the 5th. That would really be written like this, right? It would be 4 times 4. And then our 3 to the 5th would be written 5 factors of 3. We have 5 factors of 3, and we have 2 factors of 4. How could we write that one?
Could we possibly add 4 and 3?
Could we add the 4 and the 3 and get 7? And then say,
And then add up the powers?
and then say there's how many factors?
Yeah.
So 7 to the what power then would it be?
7.
7? Maybe we could do that. What do you think, Cody? What were you going to suggest? Something else? Yeah, let's get our calculators up. Let's find out, can we do it? Because it's really tempting to do that, so let's see if we can. Let's see if we can add 4 and 3 together, because those are the bases. And then we will take it to the, what power do we do that? 7th power, because there's 1, 2, 3, 4, 5, 6, 7 factors. So 7 to the 7th power. What is that? What is 7 to the 7th power? friendly number is that? 820 what?
3,543.
Okay, you guys agree with Noah? 7 to the 7th power equals that?
Yes.
Okay, so for those of you that can't figure out how to use the power key on your calculator yet, it's probably a key like this, or maybe a Y to the X key, or that you would have to press. So 7 raised to the 7th power, that might be how you put it in your calculator. Somebody else's calculator might have to use this one, 7, use that key.
Mine's
7.
different than both of
And then
those.
that yours, you have something different yet. What's yours?
Mine has an X and it has a small box.
Yeah, mine does too.
Like this?
Yep.
Yeah,
Okay,
mine.
so then you would put the 7 in, which means this is the base. This is saying take something to a power, and that something I take to a power is a 7. Because my power happens to be 7. Okay, so we gotta make sure we know how those work on our calculators, right? Okay, well then now let's do this in our calculators. 4 squared, and then times 3 to the 5th power. And if we can do this little shortcut that we said, this like, so we should get the same thing. Did we get that? 823,543. What would you get? 30,000? 3,888. 3,888. That's a long ways away from what we got the other way. So do you think we can do what we just suggested to try?
No.
No? Think there's anything else we could try then?
This is the problem where you can't add them together
Okay. Why?
because you have to have the same number. Like you have to have the same, like you have to have,
She just gave you the word.
The same base.
yes, same base.
You gotta have the same base. So in other words, when we said add 4 and 3 together and get 7, and then take it to the 7th power, we are saying that we're taking 7 times itself 3 times, or 7 times, aren't we? It's taking 4 times itself 5 times, and 3 times itself twice. Gonna be the same then? No, we just discovered that it doesn't work out. So they do have to have the same base. So you know what? We can't make this one any better than it was. That's as good as it's gonna get.
So it would be
4 squared times 3 to the 5th. You just got to leave it like that. If you have to give it as a simplified power answer, you would have to say, well, that's as good as it gets. 4 squared times 3 to the 5th. Can't do anything else. If it asks you to simplify it as then it was a value, then we would give it, 3,888 value. But if it wants a simplified power answer, that's the best we can do. So what conclusion can we make? What shortcut can we take instead of having to write out every time like we just did? What shortcut do you think we could take? If the powers have the same base,
add the
what could we do? Cody?
Add the exponent.
Add the exponents. Just add the exponents. But notice what we're not going to do. We're not going to change the base. We're going to keep the base. Isn't that what we did every time?
Yes.
We kept the base. Here was 5 in both of them. Here it was 3 in both of them. Here it was A in both of them. We kept the base. Is 3 plus 2 5? Yeah. Is 4 plus that invisible 1 there? 5?
Yes.
Yeah. Is 5 plus 2 7?
Yes.
Yeah. And remember, we couldn't do that one, could we? We tried. We thought we could do it. We tried to make, 2 plus 5 is 7 and 4 plus 3 is 7, and we tried that, but we can't do it. So if the powers have the same base, we're going to take a shortcut. We're going to add the exponents. Keep. And would you make sure you keep the base? Don't mess with it. Leave it what it is. We're saying that is what's going to be a factor, an exponent number of times. Okay, so in your homework, I do not want you to, at first anyway, I don't really care if I get to see, I don't want to know what 4 squared times 4 to the 4th power is. I want to know that you know how to simplify this and leave it as a power. So here's how you'll show me your work. Because trust me, we need to get this really planted in our brains because we're going to learn a lot of properties. So what are we going to do here because they have the same base of 4?
keep it.
Keep it. And then what are we going to do?
Take
Add their
exponents.
exponents. So that's how we can show it. We're gonna keep that base of 4, and we're gonna show that we're adding the exponents, and then we can say, you know what, simplified, our simplified power answer is what?
4 to the 6th.
4 to the 6th power. That's how we're gonna leave our answer, okay, today. Okay, go ahead and do number 2 then on your own, showing the work. Showing the step that you have to show, because we gotta make sure that we just get this ingrained in our brains, because there's gonna be so many different properties. Okay, can we use the shortcut on this one?
Yes,
Why?
because they have the same base.
Same base,
And
okay.
negative this.
Can I do this? Just write it like that.
No. Yes.
That's the base, right?
Yes.
What? Why do I have to have parentheses? Because it's a negative number, and whenever you, I don't know if I think we already got into this maybe some last year. When you're taking a negative number to a power, you always, always, always want to use parentheses. Always. So don't, because you say, well, I only need to write it once, I don't need those parentheses. Yeah, you do. Here's the reason you do, because we're taking it to a power. What's the shortcut? Negative 3 to the
Third power.
2 plus 1 power, which then does become negative 3 to the
Third power.
3rd power. Okay. So don't leave those parentheses out because I'll find them. Don't want that to happen. Okay. I think you're ready to do the next couple yourself then too. Go ahead and do 3 and 4. Showing what you're going to show me for work today in your homework. And then check me out, see if I did it right. So it's a lot less painless to show this word than having to show up multiplying out all those factors, right? Like we were doing at the top when we were proving that this is why we can use this shortcut. It works. Cody.
Oh, we're not there yet.
Okay. Anybody want to agree, disagree with 3 and 4?
Agreed.
Agreed? Okay, we got it? Okay. Well, and now when they're introducing some other stuff going on here, what do you suppose I'm going to suggest we might do in this one to get ourselves started here?
Actually, put in sequence.
Yeah, sequence. So in other words, give me a sequence then, Cody.
For which one?
How about number 5?
You can't. Well, you can, but it doesn't add up.
So we have to leave this one like it is?
Yes, because the bases are the same.
Actually, the x's are the same, and
But the
the
bases
x's are
aren't.
the base.
Huh, we have a little discussion going on here. Anybody want to join in? We don't have the, somebody thinks we do have bases, and the other one says we don't have same bases. And what is this problem really saying?
Negative 3x.
Negative 3
X.
times x to the
Third.
3rd power. Let's write that.
Oh.
Use it.
Times
Go ahead, let's
five.
write this. It means negative 3 times x to the 3rd times
5
5
x
times x to the 2nd. You know how they like to clean up algebra? They leave out things that they don't think are necessary. They don't think those multiplication dots here and here are necessary, so they left them out.
So it would be negative 3 times x to the 5th power.
Okay,
Times
let's
5.
do this. Let's show our work. Let's rearrange this. What can be multiplied times negative 3?
Nothing.
5. Constants can be multiplied times each other. Why not? We're going to learn that they really actually could be changed also to have a variable, but we're going to leave that alone today. I'm not going to confuse the issue today. And then we're going to have the x to the 3rd times the x to the 2nd. We're going to let them, say, be grouped together. So really what we're going to do here is we're going to say, I have these constants that can be multiplied. I have these exponents that can be multiplied, these powers, because they have the same base. So negative 3 times 5 is?
Negative 15.
Negative 15 times x to the, what shortcut can we
Fifth
use?
power.
No,
X
3
to
plus
3 plus 2.
2 power. And then we can say, oh, okay, now my answer is negative, oh, I'm getting into my other territory here. Okay, where do I think I'm going? Okay, so it's negative 15 x to the 5th power, yeah. Negative 15 x to the 5th. So we did have some like bases going on there. It was okay. Okay, now that you know what I just did there, go ahead and try the next one on your own. Rearrange. Remember, algebra likes constants first in multiplication and alphabetical order after that. So the only thing you should do in the first step here is just rearrange, getting them put together in the things that you think could actually be multiplied together. This one doesn't really have anything. When you're done, see if you and I agree.
Agree.
Okay. One person agreeing with me, that's good.
I agree.
Agree?
I second it.
You second it, third it, fourth it? I need tenths. Tenth. Anybody want to disagree with the rest of us? I know we don't want to take on this giants, huh? Okay. So, now, that's really, the amount of work we should be showing for that. Okay? The only one I would let you leave out is maybe you could go straight from this red right here to that, leaving out the multiplication dots right away. So in other words, this could be eliminated, go from this to that. I'm cool with that. Okay, tell me what I could write in this next step, or the first step in number 7. Cody, take a rest for a little bit. Just rest your
Number
voice.
7?
Just come rest your voice. Huh?
4 times x to the second times.
No, I don't want to even write the multiplications. I want to skip that. I just want to start rearranging because we know it means
Oh.
multiplication, right? So-
4 times negative 5, and then x to the second power times x, and then y times z.
There's just one y.
Times z to the y.
There's no
Y
X.
to the
There's
second
2
power.
y's. Times z to the second times z.
No.
Oh.
That's.
Or
Yeah,
Okay.
erase the second y.
Raise the second y.
there's
Oh,
2 y's, Noah.
I said the second y.
can't get rid of that y, he says.
And then put that first y to the second. So put a tiny 2.
Where is there a y to the second in here? Where is there a y to the second Noah in there?
Oh.
So that's why they're telling you to put that times y, because there's a y here. And so basically what's happening, you guys, is, when you're moving them, you might want to, in a problem this long, you might want to do this. I use the 4, I use the negative 5, there they are, they can be multiplied. Now I'm starting with my x's. X squared, got that. No x's in that one, got an x there. Okay, cool, I got that. Y, I got a y there, another y, I don't have one in that one. Cool, I got that. And then now I got a z squared, and another z. I got all of those. You want to make sure you don't leave anybody behind, anything behind. Okay? And now we're ready to say 4 times negative 5 is negative 20. This is going to become x to the what power? 2 plus 1.
Times
Y to the
1 plus 1.
1 plus 1
Times
times.
z to the 1 plus 2 plus 1.
So we're eventually not going to have to show that. It's going to get so ingrained. But every time we write it out today like this, we're just like making our brains say This is what I do when I'm multiplying powers with the same base. Okay, Cody?
Can I get the answer?
Yeah.
Negative 20x to the third power, y to the second, z to the fourth.
Okay, so we agree with it. 2 plus 1 in the x's is to the third power. 1 plus 1 in the y's is 2, y squared, and z to the 1 plus 2 plus 1. 1 plus 2 plus 1 is 4, isn't it? Okay, there's our simplified answer written as power. Okay? You ready to move on to another property?
Yes.
Got this one? No? Alice says no, no go. Okay. What does it look like the next property is? Power to a,
Power property.
okay.
Power of
Is that different than a product to a power? What's a product to a power? Multiplying powers times each other. What is a power to a power?
Power multiplied by power to a power.
Of taking a power times itself, exponent number of times. Okay, so we're going to put a box around that one also. We're going to say, you know what, this is another property that I got to be able to understand what it means when I say to you, oh, we need to use the power to a power property. What would we have to do? So before we make a rule for what we can do there, let's say what this really means. This really means 3 squared taken times itself 3 times. To the third power means take it times itself 3 times. That's what that means.
And then you get.
Well, now we have a power. We have a product of a power. We have a product of a power. We have a power times a power times a power. That's a product of a power. So what are we going to do?
would we take 3
3 to the
2 plus 2 plus 2.
2 times 2 times
a power. This is a product of a power. What do we do with our exponents when we have a product of a power? We add them. Right? So we changed it to a product, and now we can use our property that says, oh, well, now they all have the same base, so all we have to do is add their exponents, and we'll have our power answer. It says 12 on there.
I gotta get on my math and not my
Okay, Cody, just let me finish this, okay? You do it with us. Okay, B. Let's try that one. What is this saying?
x to the 4th
X to the 4th power times,
times x to the 4th power.
any more times?
No.
No, it says twice do it, right? Okay, so now, this is now a product to a power, or, so a product of powers, I mean. So now that means we can do the shortcut that says they have the same base, so we would add their powers, their exponents together, and we would say we have x to the 8th power. Okay, well, we could do this all day, but let's develop a shortcut right now that you can see we should be able to do. We should be able to go from here to here by not having to write out all that other stuff in between there. What do you think we could do? Devontae?
2 times 3.
Okay, so we could have taken 2 times the 3 and we would have gotten 6. Here, would that work here? 4 times 2 is 8. Okay, so when taking a power to a power, it says what? Multiply the exponents. When you're taking a power to a power, you can use the shortcut. Instead of adding, you're going to multiply this time. Okay, so let me show you how we're going to show work for these before Cody thinks he's going to disappear on us. Okay, so practice here. We have a power to a power. 4 to the 4th power is being raised to the third power. That's where the power to a power comes from. When you say it, you say 4 to the 4th power raised to the 3rd power. So we're going to do 4 to the 4 times 3 power. And what is 4 times 3?
12.
Yeah, so it's 4 to the 12th power. That's how we show our work for those. Okay. Okay. Now, look at here. here, why do you suppose this is a crazy, I mean, does this like throw you off? What's going on here? We got these parentheses and then we got these brackets. Why do they have both?
Because it's a negative 3.
Aurora?
Because for negative and parentheses, you're typing that by a number.
Yeah, so we notice here how we had when we had a power to a power, we had the power in parentheses, so we could put the power it was being taken to outside of it. These are like those parentheses right here. This says this power, negative 3, raised to the 5th power. That power has to be raised to the 2nd power. So we just use a different type of grouping symbols. We use our brackets instead. So we're going to have negative 3. That's our base. And what would we show?
To the 10.
What would we show?
5 times 2.
5 times 2. And can we ditch these parentheses?
No.
No. Negative 3 to the 10th power. Okay. Go ahead and do that last one then on your own for that one before we move on to another property. When the clock changes to 11:59, you can come take the sample. Okay. Do I need parentheses in this one?
No.
Okay. So when in this back in number 9, when we got rid of those brackets, that was because getting rid of the brackets was this part, wasn't it? But we couldn't get rid of the parentheses in that one because of the negative. So here we're getting rid of the we're getting rid of the parentheses by doing the multiplication. So what do we get? X to the 20th power. Okay. So we've got two products. We've got two properties in me. What was our first one? Our favorite one, did we say it right? What is it? Product of powers. What are those powers? When you're multiplying powers, what has to be true? The base has to be the same. And if the base is the same, you can do what? Add the exponents. Okay? And keep the base. Now, what's the other property we've talked about? Power to a power property. When you take a power to another power, you're going to do what with the exponents? Multiply them, and you keep the same base. And that one also, don't you? Okay? Well, now let's throw in a third one. Power of a product. Oh, now notice this didn't say product of powers. It says a power of a product. So in other words, there's a multiplication problem going on that's being taken to a power. That's really what that is saying. Power of a product. There's a multiplication problem going on. That's the product. It's being taken to a power. Here's our multiplication in A, 2m. So 2 times m, there's our product. It's being taken to a power. Okay, so let's write this out, what this really means. We have 2m to the 4th power. It really means 2m times 2m times 2m. We have 4 factors of 2m. If we rearrange those, we have those 4 2's that can be multiplied together. We have those 4 m's that can be multiplied together. So what would this become?
2.
It's 2 to the 1st power, 1st power, 1st power, 1st power.
Oh,
It's really 2 to the 4th power. And then these are m's to the 1st power, so it becomes m to the 4th power. Now, in this one, we will take 2 to the 4th power and see what it is. 2 times 2 is? Times 2 is? Times 2 is? 16. So this one does become 16 m to the 4th. 16 m to the 4th is what the result is. Now, we didn't apply any shortcuts to this other than the shortcut of after we rearrange them. Now we could do our power I can't even say it right now because we've added too many. Product of powers. We have 2 to the first power that is being multiplied, m to the first power, so that's when we can add the exponents. So we did apply a property in the process of it. Okay, here we have 3xy to the third power, so that means we have 3xy times itself 3 times. So we really have 3 3's that could be multiplied together. We really have 3 x's that could be multiplied together. We really have 3 y's that could be multiplied together. So 3 times 3 times 3 is really 3 to the what power? Third power. X times x times x is x to the third power. And y times y times y is y to the third power. And then now let's just clean this up even a little bit more. 3 times 3
27.
is 9, and then times 3 again is 27. 3 to the third power is 27. So we'll have 27x
To the
to the third power, y to the third power. Like my 3's kind of got lost up there. Maybe I'll change their color so you can see it. Okay, so we have 27 x cubed, y cubed. Now, notice something. I want you to, here's where I want you to zero in. I'm going to take my blue marker and I'm going to put a box around this right here. And this right here. What shortcut do you think we could take when it says, when you're taking a product to a power, we could do what? What do you think, Aurora?
Take each base times the exponent.
Okay, so each base, but you know what we're going to call these guys? They do end up becoming bases, but in the multiplication problem, they're called factors. Okay, so we're going to take each factor to that power, and then it does become a base. You're right. So instead of having to write out everything we did there, we're going to shortcut that a little bit by taking each factor to the power. So number 11, how many factors are there in this multiplication?
2.
2. What's one of the factors?
7.
7. What's the other factor? 8. Take each of them and give them their own power of 2. Take each of them and give them their own power of 2. Instead of having to write out 7a times 7a, rearrange it, just give each of them their own power of 2. What is 7 squared?
42. No.
49.
49. And a squared is going to stay a squared, isn't it? Okay, there we go. That was a lot shorter, wasn't it? Okay, how many factors do we have in number 12? 3. To start out with, in our multiplication problem here, we have this factor, and this factor. So each of them gets their own power. So we're going to do x to the 4th power. It has to be raised to the 2nd power, so what are we going to have to do with that x to the 4th?
Times 2.
Put it in
Times
parentheses. No, we're just going to give it its own power right now. Put it in parentheses. X to the 4th power has to be given the power of 2, so it's going to be taken to the 2nd power. Times y to the 3rd, give it parentheses because it's a power that's going to be raised to another power. And then z, does it need to have parentheses around it? Why not?
It's not
Because we don't show the power, right? It's invisible. What is that invisible power? 1. So we can just give it its power right away. Okay? Okay, that was a product to a power. Give each factor in the product that power, that exponent. Now we look and we say, do we have any other properties that need to be applied to continue simplifying this? What do we have here when we have x to the 4th power raised to the 2nd power?
We're taking the exponents times each other.
So we're taking a power to a power, and what do we do when we take a power to a power? We multiply it. And is this a power to a power here, the y's? That's another power to a power, isn't it? 3 times 2. And then our z squared is just going to stay z squared. So what do we end up with? X to the 8th power, y to the 6th power, z to the 2nd power. So we learned 3 properties, but sometimes within a simplifying problem, we have to apply more than one property to help us simplify it. So any parts of this unclear? Did we get all the way to the end? That's the end, right? Okay. Anybody have any of them that are unclear to you at this point that you want to talk about? Okay, get out a sheet of loose leaf paper.